Greetings and welcome to Make Programming Fun Again. My name is Karol Moros, and in today's video we are going to be reading the Rust programming language book by Steve Chlebnik and others. And more specifically, we are going to be programming a guessing game. This is an exercise from chapter 2 of this book. And firstly, we are going to implement it almost exactly like in the book, but hopefully we'll also manage to do some challenges. For example, we could add high scores, or we could add a timer, and So without further ado, I'm going to begin by reading the book, and then we are going to implement it in a code editor. Chapter 2. Programming a guessing game. Let's jump into Rust by working through a hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. You'll learn about let, match, methods, associated functions, external crates, and more. In the following chapters, we'll explore these ideas in more details. In this chapter, you'll just practice the fundamentals. We'll implement a classic beginner programming problem, a guessing game. Here's how it works. The program will generate a random integer between 1 and 100. It will then prompt the player to enter a guess. After a guess is entered, the program will indicate whether the guess is too low or too high. If the guess is correct, the game will print a congratulatory message and exit. Congratulatory.
Congratulatory.
Congratulatory. Congratulatory. The game will print a congratulatory message and exit. So this is a difficult word, but it basically means a message that congratulates you. Setting up a new project. To set up a new project, go to the projects directory that you created in chapter 1 and make a new project using cargo like so. A side note, the source code that I will be implementing in this video will be available on my GitHub, and I will put a link in the description under this video. Okay, cargo, new guessing game. And we can cd, and we have a Git repository, and we can commit, git add, git commit, -m initial commit, and we can check that the program compiles and runs. Okay. The first command, cargo new, takes the name of the project, guessing game, as the first argument. The second command changes to the new projects directory. Look at the generated cargo.toml file. Okay. It looks kind of similar, except that our project has been generated with edition 2024. As you saw in chapter 1, cargo new generates a hello world program for you. Check out the source main.rs file. Okay. Main.rs. Yep, exactly like this. So it's a hello world program, and the main function is the entry point of the Rust program, just like in C. Now let's compile this hello world program and run it in the same step using the cargo run command. Okay, I've already done it. Reopen the source main.rs file. You'll be writing all the code in this file. The first part of the guessing game program will ask for user input, process that input, and check that the input is in the expected form. To start, we'll allow the player to input a guess, enter the code in listing 221 into source main rs. Okay, I'm going to put this on the left side and use stdio, and I'm going to print ln guess the number, print ln please input your guess. Let mute guess equals string new. So what this does is it allocates a new mutable string. I'm guessing it's like heap allocated because it can grow. And we need to make it. We need to declare it as a mutable variable. Otherwise, we won't be able to modify the value of this variable. This is the way things are designed in Rust, and I think it's a pretty good design, honestly. Okay, and then we read a line into this string, and we call expect failed to read line, like so. And then print line, you guessed this. Okay, so this is the syntax that obviously still works, but actually from some point in Rust's history, you can actually enter the interpolated value like so. So instead of putting the interpolated value after the format string, put it inside the format string. Also, I'm not exactly sure if I have correct like tree sitter installed for Rust, but I think it's not so important. The code contains a lot of information, so let's go over it line by line. Okay, so I'm basically going to summarize it because I kind of understand this code. So this imports the crate called stdio, and we need it to read from standard input. And I'm not exactly sure if this read line comes from. Okay, yeah, maybe we also need this read line. We also need it for this read line thing. I wonder if we removed it and used stdio like so instead, would it still compile? Yes, it did still compile. So okay, so there are no traits, but we are importing. We are only using. I think for now the stdio crate is. We only use it. We only use this use statement in order to be able to call the IO crate without having to specify the whole name. Okay, these are macros, and they print the string in brackets and out to standard output. Then this is a mutable variable, and we allocate a new string on the heap. And yep, so basically Rust lets you declare a variable without specifying its type, as long as the type can be I forgot the word. Yeah, that was a complicated word for the language guessing the type of a variable. I will remind you in like somewhere. I will remind you later on in this video. Okay, now the program is getting interesting. There's a lot going on in this little line. We use the let statement to create a variable. Here's another example. This line creates a new variable named apples and binds it to the variable 5. In Rust, variables are immutable by default, meaning once we give the variable a value, the value won't change. We'll be discussing this concept in detail in the variables and mutability section in chapter 3. To make a variable mutable, we add mut before the variable name. Okay, this is a comment like in C++. Do we have multi-line comments? We do. Great. Returning to the guessing game program, you know that let mut guess will introduce a mutable variable named guess. The equal sign tells Rust we want to bind something. Oh yeah, I remember the word. Rust has type inference, just like Go. So we can define a variable using the keyword let, and we do not need to specify the type as long as it can be inferred. And in this situation, on the right hand side of this assignment expression, there is an expression of type. Like there is a value of type string. So Rust can infer that this variable guess will be a string. And this is what happens. Returning to the guessing game program, you know that let mut guess will introduce a mutable variable named guess. The equal sign tells Rust, okay, on the right of the equal sign is the value that guess is bound to, which is the result of calling string new, a function that returns a new instance of a string. String is a string type provided by the standard library that is a growable UTF-8 encoded bit of text. The : syntax in the : new line indicates that new is an associated function of the string type. An associated function is a function that's implemented on a type, in this case string. This new function creates a new empty string. You'll find a new function on many types because it's a common name for a function that makes a new value of some kind. So it's basically like a constructor, but not really a constructor because in Rust they don't really have classes. So instead it's just, so this new is not really a specific way that the language works, it's just a convention. In full, the let mut guess equals string : new line has created a mutable variable that is currently bound to a new empty instance of a string. Ooh, get. Okay, let's lock in. Receiving user input. Recall that we included the input-output functionality from the standard library with use_std_io on the first line of the program. Now we call the stdin function from the IO module, which will allow us to handle user input. If we hadn't imported the IO library with use_std_io at the beginning of the program, we could still use the function by writing this function call as stdio_stdin. The stdin function returns an instance of stdio_stdin, which is a type that represents a handle to the standard input for your terminal. Now the line readline calls the readline method on the standard input handle to get input from the user. We're also passing a mutable reference to guess as the argument to readline to tell it what string to store the user input in. The full job of readline is to take whatever the user types into standard input and append that into a string. Okay, and what does okay, so readline specifically takes a mutable reference to a string, Nothing else. No interfaces or anything. Okay. The full job of readline is to take whatever the user types into a standard input and append that into a string without overwriting its contents. Okay. And this is a reference, and this is this is a reference, and it's a mutable reference, and that is related to the Rust borrow checker, and it's basically one of the difficult parts of the language, and I think the book will talk about it more. But basically, in this situation, what it means is that we need to pass, we need to borrow the ownership. This variable guess owns the memory behind string u, owns that instance, and in here we need to borrow the variable as a mutable reference in order to be able to read to it. Okay. Now this expect is a method on IOResult, and when we call expect, it will return the OK value if it's OK, and it will panic with this message if it fails. Okay. We are still working on this line of code. We are now discussing a third line of text, but know that it's still part of a single logical line of code. The next part is this method, .expect fail to read line. We could have written this code as like this. It's like in one line, but even if we did, the Rust formatter would reformat it as multiple lines. However, one long line is difficult to read, so it's best to divide it. Okay, hang on, I'm going to enlarge the cursor. Okay, better. However, one long line is difficult to read, so it's best to divide it. It's often wise to introduce a new line and other white space to help break up long lines when you call a method with the .method name syntax. Now let's discuss what this line does. As mentioned earlier, readline puts whatever the user enters into the string we pass to it, but it also returns a result value. Result is an enumeration, often called an enum, which is a type that can be in one of multiple possible states. We call each possible state a variant. Chapter 6 will cover enums in more detail. The purpose of these result types is to encode error handling information. Results variants are OK and error. The OK variant indicates that the operation was successful and it contains the successfully generated value. The error variant means the operation failed and it contains information about how or why the operation failed. So yes, this returns a result and we can handle it not gracefully. Like, this is basically a failing fast, and what this means is that if we fail to read a line, we're going to panic with this string. Another way we could do it is using unwrap, and the only difference between expect and unwrap is that with unwrap you cannot specify the panic message. Values of the result type, like values of any type, have methods defined on them. Okay. Also, as a side note, it's kind of like if in Go, if we wrote if something error equals operation error is not null, we would log fatal. That's more or less the same idea, except that with Rust there is a dedicated syntax for it, and sometimes it's nicer, and sometimes I think it's kind of more complicated than than the way we would write it in Go. But you know, you pick the best tool for the job. Values of the result type, like values of any type, have methods defined on them. An instance of result has an expect method that you can call. In this instance of result, if this instance of result is an error value, expect will cause the program to crash and display the message that you passed as an argument to expect. If the readline method returns an error, it would likely be the result of an error coming from the underlying operating system. If this instance of result is an OK value, expect will take the return value that OK is holding and return just that value to you, so we can use it. In this case, that value is the number of bytes in the user's input. If you don't call expect, the program will compile, but you'll get a warning. Okay, will it? Okay, let's see. Cargo run. Okay, so we are still getting the same result. It's just that we are getting a warning because we did not handle the error. Okay. If you don't call expect, the program will compile, but you'll get a warning. Unused result that must be used. Okay. Rust warns that you haven't used the result value returned from readline, indicating that the program hasn't handled a possible error. The right way to suppress the warning is to actually write error handling code, but in our case we just want to crash this program when a problem occurs, so we can use expect. Okay. Printing values with placeholders, and okay, yeah, so this mentions what I mentioned before. You can write you can interpolate strings using like the postfix syntax, but you can also write them directly. You can also write the interpolated value directly inside the format string. Okay, so now we can test the first part. And yeah, we have seen that it works like intended. Cargo run. We can enter number 42, and you can also see that even though we did not include a new line in the string, we are still getting a new line at the end of this line, and we can fix this by basically generate, like, okay, you can just say guess equals guess trim. Okay. Okay. So the trim is on. Okay, so we can fix this by reassigning to guess, and this is going to create a new variable which is of a different type, but it's doesn't really matter for our purposes. And if you run cargo run now, we are not getting an additional new line after this line. And what's happening is that this is a string, and this returns a slice of string, so it's actually a different type from a string, and it is actually backed by the same underlying piece of memory as a string, because it's literally like a smart pointer to an existing string. I wonder if we tried to assign it to a different variable, so like if we call it trimmed, and guess trimmed. And now if you try to modify guess equals other value to string, like so. Cannot assign to guess because it is borrowed. Borrow occurs due to deref coercion to string. Okay. So we cannot reassign. Can we reread? We cannot reread anymore because it was already borrowed afterwards. And okay, great. So actually there is since this is a pointer to a smart pointer to a string, we cannot we can only borrow it here, and after we borrow it there, we cannot really reassign it anymore. Can we do it? Can we do it with a clone? Okay. So we can clone it with guess clone, and then we cloned like so. Okay, so this way it should compile. We are kind of wasting memory, but it works. Okay. Yep, that was just an experiment. Okay. And we can still call it guess, even though it's a different type, because Rust supports variable shadowing. So if we create a new variable with the same name in the same scope, like literally the same scope, this variable exists before this redeclaration, and after this redeclaration, this value is going to be replaced, basically. Okay, in the next section we're going to have to generate a pseudo-random value, and there is no pseudo-random number generator in the Rust standard library, but there is a crate called Rand. I think it's named after the South African currency. Joke, okay. And yep. And I remember the way it is used in the book is kind of obsolete, and that the LSP is going to tell us how it works right now. Also, the book tells us to add the dependency to the project using by simply modifying the cargo.tom file, but since some later version of cargo, you can just specify cargo add rand, and it's going to add the crate to the project. Okay, so okay, so we installed cargo, we installed the crate, and we can now generate a random number. Okay, so use rand RNG, and now we are getting a warning because we are not using this import. Let secret number equals rand Fred RNG gen range 1 to 100. Okay, and straight away we're getting warnings. So Fred RNG is deprecated, so we're going to have to replace it with RNG. And then gen range was misspelled, and it's also deprecated. Okay, it's called random range, like so. Okay. And yep. So right now it basically tells us to print out the number. The secret number is secret number, like so. And cargo run, like so. Secret number is 29, so I'm guessing it's 30. Okay, it doesn't matter because we have not implemented the game loop yet. Okay, so in this situation we actually need to add the import, because it imports a trait, and if we remove this line, the code wouldn't compile anymore, because it does not contain, because we wouldn't have this trait in scope. The way the book defines it is, first we add the line use rand : RNG. The RNG trait defines methods that random number generators implement, and this trait must be in scope for us to use those methods. Chapter 10 will cover traits in detail. Next, we are adding two lines in the middle. In the first line, we call the rand thread RNG. We don't call it because it's deprecated. We're calling rand RNG and the method random range, and we are passing a range. And this range, I think this is an inclusive range, which means it does include both the first value and the second value. So it includes all values from from 1 all the way up to 100. Next, we're adding two lines in the middle. Okay, it says it's seeded by the operating system. Then we call the gen range. This method is defined, gen range. Okay. You won't just know which traits to use and which methods and functions to call from a crate. So each crate has documentation with instructions for using it. Another neat feature of Cargo is that running the cargo doc open command will build documentation provided by all your dependencies locally and open it in your browser. Okay, let's see. Cargo doc open. Okay. Also, I don't think this is my default browser anymore, but okay. The second new line prints the secret number, but actually let's admit that this local HTML documentation is really neat. So we can get documentation for libc. Okay. Why do we have a libc crate? Can we call like printf in here? We can. Okay. I want to call printc. Let's see. Libc printf, and we need to pass it a const char. Okay, so is it like it's going to complain, right? Use libc. Can we do it? Okay. Okay, I don't know how to directly call C from Rust. Doesn't matter. We also have rand chacha, and this I think is based on the chacha cipher. And yep, because we're not really like the random number generators are not really random, they are pseudo-random. which means they are using a cryptographic algorithm that behaves almost like it's giving you random numbers, except that they are just pretending to be random. Okay, so okay, so the next thing we're going to have to do is we're going to implement the game loop, and we're going to use the loop statement, which starts an infinite loop, and we can then parse the number as an integer, and then we can expect failed to parse number. And this is because okay, so this is a lot to digest. We trim the initial string, and this returns a string slice, and then we call parse, and this parse is going to infer the type from the type annotation in here, and i32 is a 32-bit signed integer, so exactly the same as an int in the C standard library. And then we call expect because parse returns a result. So we can remove this statement, and we can do the same thing as they do here. We call the CMP method on, and we're going to have to include another trait, use std CMP ordering. Okay, this was not because we did not need a trait, we just needed this enum. So if you win, then we can just break the loop, and let's see, cargo run. Let's say the number is 42, 50, 80, 90, okay, 85, 83, 82, okay. So the guessing game works, and I went very much ahead of the book. But basically, this is we use the match statement, which is used for pattern matching, and we call the CMP method on the guess. Guess is an i32, and CMP takes a reference and a read-only reference to another value, and these are values, the same values as used in by comparison functions in the C standard library. So if the compared value, if the guess is smaller than the secret number, we print too small. If it's greater, we print too big, and if it's equal, it means you win. And this way, okay. Yeah, so this ordering is an enum, but we could probably just try to match on the actual values, or maybe not. And 5 new lines, okay. So this is a match expression made up of arms, and this way we basically implemented this whole game. Oh, and by the way, they actually want to use U32. I think an i32 is fine. Okay, and then this part also explains variable shadowing. So even though we already have a variable called guess, we declare a new variable which is also called guess, and it's a different type, and it's fine because this variable exists before the redeclaration, and we can basically just shadow variables in ad infinitum. So we have a loop, and okay, handling invalid input. Okay, so instead of calling expect, that's what happens. Okay, that's actually a neat statement. Instead of calling expect, we run it like so. Number, if it returns okay, we return the number. And if it returns something else, we call continue, and this way we basically just ignore an invalid value. Okay, so if I type quit, it just ignores it and goes to the next iteration. 60, 80, 70, 65, 64. Okay. So I'm going to commit now. The game as in the book. Okay. What is the next? Okay, so this was the guessing game as implemented in the this was the guessing game as implemented in the book, and what I want to implement next is I want to first implement checking the counting the number of guesses. So I'm just going to say let mutable count equals 0. So if we did not match correctly, we can iterate the number of guesses, and we cannot use ++ because that iterator does not exist in Rust. So basically, instead of typing you win here, I'm going to print you win outside of the loop. And we can say you needed, you win in count attempts, like so. So to recap, we have a mutable variable which is an integer. It is inferred to be an I32, and we iterate it on every time we guess incorrectly, and if we guess the value correctly, we break the loop, and then we print you win in number of attempts. Also, I think we could start with 1, because if we break, then this wouldn't be called, and then we would get an invalid number. So let's try again. So cargo run, my guess is 42, it's too small. 50, 48, 45. Okay. So indeed, we tried 1, 2, 3, and 4 attempts. And now what we would like to do is we want to try to count time. So to that end, we're going to need the monotonous clock. And a monotonous clock in programming is basically the number that indicates how much time has passed since the system was started. Monotonous clock in Rust. Monotonic clock, okay. How is it written? Where is the source code? And clock. How does it work? Okay, it works. Wait, it's way too complicated for me. Duration. Okay, yeah, this is, I guess this is the reason I don't really like Rust, because you get all these crazy types, but you have to learn to at least understand. So this is like a synchronous arc. This is a reference counted variable. Oh boy. How do you actually read it? Can I like how to read the monotonic? Can we get the hardware clock? Clock get time. So how do I read this monotonic? Rust. STT time. Okay. So it looks like there is a crate called a struct called instant. So use std time instant, and we start in here. Let start time equals instant new. No, it's called now. Okay. And elapsed equals start time elapsed, and this is of type duration. And as can we get it as milliseconds? What does the duration have? Duration and duration from secs as milliseconds. Okay. And then we can get, okay, we could actually get as a float, okay, as secs f64 time elapsed elapsed. Okay, let's see. Cargo run 42, 50, 70, 80, 64, 67, 68, 69, okay, 75, 78, 77, 76. Okay, we took 26 seconds. This sounds kind of believable. And now let's see if we can also show the duration at every moment. So let elapsed equals start time elapsed as seconds f64, like so. Time elapsed seconds, and the same here. So now we can show the elapsed time every time you guess. 70, 50, 30, 20, 15, 18, 19, okay. 8 attempts, 18 seconds. So also what I would like to see, I would like to see if there is a way to like format this float. So we can round it nicely. So round a float in Rust. Okay, so it's handled in the println thing. So like so. Okay. Okay, let's see. 42, 60, 55, 80, 90, 95, 99, 97, 96, okay. 9 attempts, 19.92 seconds, okay. That's actually quite nice. And these are all the challenges I wanted to implement in this video. Let me know what you think about my my rants. Like, no, it's not a rant. Let me know what you think about my I'm basically just you know, goofing around with Rust. I'm not an expert in Rust. I'm just playing around. So if you enjoy watching this type of content, please consider subscribing to my channel. And if you want to see more of these videos, please make sure to watch it all the way to the end and liking the video. This way I will be eligible for what was it called? I will be eligible for monetization quicker. And you can also sign up for the Discord waiting list at discord.moros.dev. And once 100 people sign up for the list, I'm going to create a Discord server, and then we can happily spend all days talking about software. So thank you for watching, and I will see you in the next video.